In this video, we're going to talk about multiplicity and what it is. So we're going to start by looking at the graphing calculator at the graph of f of x equals x plus 3 times x minus 2. First, we're going to identify the x-intercepts. So here's my graph. I can click on the x-intercepts and see that they are located at -3 and +2. Question 16 says, how are the factors related to the x-intercepts? Well, this is related to what we talked about before. We set each factor equal to 0 and solve to find the x-intercepts. Now we're going to look at another graph. This one is g of x equals x minus 2 times x minus 2 times x plus 2. So here's that graph. Again, we want to identify the x-intercepts. So I have an x-intercept here at -2 and another one at +2. Question 18 says, what is different about the behavior of the graph at x equals 2 and x equals -2? Why do you think this happens? So when I look at the graph, I see that at -2, the graph is just going straight through the x-axis. At +2, the graph does not go through the x-axis. It comes down and hits the x-axis and then turns back around and continues back upward. And you might suspect that this happens because looking at my equation, I have x minus 2 as a factor in my equation twice, and x plus 2 is only a factor in the equation once. And remember, x plus 2 is going to lead to the x-intercept at -2, and x minus 2 is going to lead to the intercept at +2. Now we have a third graph to look at. F of x equals x minus 2 to the third times x plus 4. So here's my graph. X-intercepts are here at -4 and at +2. What do you notice about the behavior around the x-intercepts? So at -4, the graph is again going straight through the x-axis. At 2, the graph goes through the x-axis, but it kind of does this little wiggle and flattens out around the x-axis. So you can see that these are two different shapes. So this brings us to the idea of multiplicity. The multiplicity of a 0 is the number of times that the factor that produces that 0 occurs. So looking at these examples, here my 0 at 2 has a multiplicity of 3, and my 0 at -4 has a multiplicity of 1. If there is no power on the set of parentheses, then it's an automatic 1. In this problem, my 0 at 2 has a multiplicity of 2 because x minus 2 occurs twice. At negative 2, there's only a 1 factor of x plus 2, so at negative 2, there's a multiplicity of 1. Here, both factors have a multiplicity of 1 at negative 3 and positive 2. So I'm going to highlight this in my notes because it's actually very important to remember. So the power on the set of parentheses that makes that 0 is the multiplicity of that 0. Multiplicity tells us what happens at the graph at that point. So if there is an even multiplicity of that factor, then the graph touches the x-axis and turns around. If it's an odd multiplicity, then it crosses the x-axis there. And if the multiplicity is greater than 1, then it tends to flatten out there as well. So if the multiplicity is just 1, then that's when we see the graph go straight through, like this, without doing any flattening out. So multiplicity of 1 goes straight through. Multiplicity of 3 goes through but has this flattening out area. And then this is a picture that shows that as well. Odd multiplicity, we see the graph going through. Even multiplicity is the touching and turning around situation.